Hello students, welcome to my YouTube channel ScopeIIT. Today we will discuss about the topic asymptotic notation in design and analysis of algorithm subject. Now, what do you mean by asymptotic notation? Asymptotic notation are the mathematical tool that is used to analyze the performance of algorithm by understanding how their efficiency changes as the input size grows. Okay. So in short, we can say that what do you mean by asymptotic notation? It is a mathematical tool that is used to analyze the performance of algorithm. That means how well your algorithm will perform. Now, there are three main types of asymptotic notation we have. One is your big O notation, omega notation, and theta notation. Okay. So first I'll explain this in my words, then I'll explain you proper definitions and all. See. So basically, there are three different types of asymptotic notation we have. So first one is your big O, then you can say your omega, and the third one is theta. Okay, this is a symbol. This is known as big O, this is known as omega, and this is known as your theta notation. Now, what do you mean by big O? Big O, that means worst case. Big O means worst case. Omega, that means you can say best case. And the theta, that you can say average case. Okay. Other than that, even you have to remember the equation, which is very important for you. So for big O notation, the equation is f of n should be less than or equals to c dot g of n. Similarly, the equation for best case is f of n should be greater than or equals to c dot g of n. Okay. Then equation for your theta case is c1 dot g of n should be less than is equals to f of n, which should be less than is equals to c2 dot g of n. Okay, now here you can see f of n is greater than c dot g of n. That means this is your which case? Best case. So here this is nothing but best case. Okay, and f of n is less than c dot g of n. Okay, so this is nothing but your worst case. So your average case is nothing but combination of your best case and worst case. I hope it's clear. Next, now we'll understand it by proper definition. See, so big O notation. A big O notation represents the upper bound of the running time of an algorithm. Okay, what do you mean by upper bound? Because worst case, that means it will give you the biggest, or you can say maximum time complexity. Okay, so that's why represent the upper bound. Here important keyword is upper bound of the running time of an algorithm. Therefore, it gives worst case complexity of an algorithm. And I already told you the equation f of n should be less than is equals to c dot g of n. You can see the graph. Okay, so in this graph, see what we said, f of n is less than. So as it is less than, your f of n will be below and c dot g of n should be upper. Okay, that you should take it. Now, similarly, if I say the graph for omega notation, so how it will be? F of n is upper side and c dot g of n should be lower one. Let us check. See, this is your graph for omega. See, f of n is upper side, c dot g of n is lower side. Okay, so when you are drawing this graph, you should take care of this point, which is very important. Okay, now, so what is omega notation? Omega notation represents the lower bound. Like worst case, that represents the upper bound. So omega notation represents the lower bound. Otherwise, definition is same. Just there is upper bound, here lower bound. Okay, thus it provides the best case complexity of an algorithm. Now let us see theta. Okay, so theta notation encloses the function from above and below. Since it represents upper and lower bound of the running time of an algorithm, it is used for analyzing the average case complexity of an algorithm. See, now this is the equation. So in this equation, you can see that f of n is middle. Okay, c1 dot g of n and c2 dot g of n. So which is the biggest one? c2 dot g of n is greater than f of n. So see, first c2 dot g of n, then f of n, and then c1 dot g of n. Okay, so if you know this equation, even you can draw the graph also by yourself. Understanding? And if you will read the definition, so here in your that one big O notation we said upper bound, in omega notation lower bound, so in theta notation we will have combination, you can see upper bound and lower bound. Okay, one more point, you should make a note of it. See, as I told you, there are three main asymptotic notation, that is your big O notation, omega notation and theta notation. Okay, other than that there are two more notation, that is your little o and your little omega. Okay, so there are two more notation basically. What is this little o and little omega? Okay, what is the equation for big O notation? The equation for big O notation is f of n is equals to big O of g of n. Okay, but what was the final equation? It is f of n. Okay, so this big O will be replaced with f of n should be less than is equals to c dot g of n. Similarly, what is the equation for little omega? Little o, that is f of n, if it is equals to little o of g of n. Okay, so then it will become f of n is less than c dot g of n. Okay, so your big O notation and little notation is same, just the difference is in big O notation we have this equals to symbol, whereas in little o notation we don't have equal to symbol. Okay, same here in the omega also. So in omega, what was the formula? Your f of n should be greater than is equals to c dot g of n. Okay, so what is the equation for little omega? Equation for little omega is f of n should be greater than c dot g of n. So here also we will not have equals in little omega. That is the only difference between little o and little omega compared to big O and big omega. Okay. Next, now let us solve some previous year GATE question based on this topic. This is a GATE 2008 question. Consider the following functions. So here they have given you some function. First function says that f of n is 2 ka power n, g of n is n factorial and h of n is n ka power log n. Okay. Now, to solve this question, okay, you should be aware of that 2 ka power n is greater than n factorial or is it less than n factorial? Okay, if you are not aware of it. So for this, what you need, for this we need order of growth. Before solving that question, I'll explain you how to get order of growth. Okay, so I'll give you some points, you can note it down, which is known as order of growth, or even it is known as comparison of various time complexity, both you can say. Okay, now see, big O of C. Big O of C. C means any constant. It can be 1, any constant. Okay, so constant value always have the lowest time complexity. Okay, so big O of C, which is less than big O of log n. Okay, then log n actually is less than big O of log n. And big O of log n actually is less than big O of n ka power 1 by 2. And big O of n ka power 1 by 2 actually is less than big O of n, which is less than big O of n log n. This is in continuous, which is less than big O of n square, which is less than big O of n cube, which is less than big O of, you can say, n ka power k. K means any term we can say, okay, which is less than big O of 2 ka power n. Okay, so usually 2 ka power n has the highest priority, but even we can say if you have big O of n ka power n, okay, because here it is n ka power k, okay, but if you have n ka power n, whatever is this one, below and exponent both are same, that is having more higher priority. So this is the order of growth. Based on this order of growth, you can answer that question which I have shown you. Okay. Now, so see, f of n, that is 2 ka power n. Okay. So now here if you see, f of n value is your 2 ka power n. Another, this is your f of n. Then g of n value, that is n factorial. Okay, remember g of n value is n factorial. Remember n factorial is always equals to n ka power n. Okay, because we solve recurrence also. So n factorial is always equals to n ka power n. Okay, and your h of n value is n ka power log n. Okay, now here if you will compare f of n and g of n. Okay, if we'll compare f of n and g of n. So see, which one of the following statement about the asymptotic notation behavior of f of n, g of n and h of n are true? Okay, so now let us see. Option A says that, first of all we'll solve option A. Option A says that f of n is equals to big O of g of n. Okay, now what do you mean by big O? Big O is nothing but basically, you know the equation for big O. That is f of n is less than is equal to c dot g of n. Correct, f of n is less than is equal to c dot g of n. Now let us compare the value. What is the value of f of n? F of n value is 2 ka power n. So they are telling that is 2 ka power n value is less than or equals to n ka power n. We have already solved this. I've already explained you in order of growth. So 2 ka power n value is less than n ka power n. Okay, so this first condition is satisfied. Now, let us take the second condition. Second condition says that g of n is equals to big O of h of n. So here also we have big O. So that means it will become g of n is less than or is equals to c dot h of n. Okay, so what's the value of g of n? N ka power n, which is less than or is equals to c dot g of n. C dot h of n. H of n value is n ka power log n. Okay, so now here you can see denominator are same. Okay, so if we'll compare n, is n less than or is equals to log n? No, n is greater than log n. So here second condition is not satisfied. Hence I can say that option A is not correct. Okay, now let us check for option B. But here, if you will check here in option B properly, this one, g of n is equals to big O of h of n, which we have already solved. Okay, then no need to solve option B, because as per this, h of n, g of n and h of n, all conditions should be true, not one. So option B is also not possible. Now let us see option C. Option C says that g of n is equals to big O of f of n. Okay, so that is g of n is less than or is equals to c dot f of n. Okay, so what's the value of g of n? That is n ka power n. Is it less than or is equals to f of n? That is 2 ka power n. Okay, we have already solved this. 2 ka power n value is greater than, 2 ka power n value is less than n ka power n. But here what they are telling, 2 ka power n value is greater than, which is again false one. Okay, so option C is also not right. So now we already got option D is the correct one, but still we will cross check. Okay, so now let us check option D. H of n is equals to big O of f of n. Okay, so now what is h of n value? H of n is n ka power log n. So n ka power log n is less than is equals to big O of f of n. F of n is 2 ka power n. Yes. So n ka, as per my order of growth, n ka power n log n is less than or is equals to 2 ka power n. That is true. This is true. Now let us check for the second one. G of n omega. Omega, that means g of n is greater than or is equals to f of n. So what is g of n value? N ka power n is greater than or is equals to f of n, 2 ka power n. So yes, n ka power n is greater than 2 ka power n. So this is also true. Hence I can say that the correct answer is option D. I hope it's clear. Next. Now this is your GATE CSE 2011 question. Which one of the following given option provides the increasing order of the asymptotic complexity of a function f1, f2, f3, f4. Okay, so to solve this question, actually the order of growth which I have given you, that is important. Okay, so I have added that order of growth here. So f1, that is 2 ka power n, f2, that is 3 ka power n by 2, f3, that is n log n, and f4, that is nothing but n ka power log n. Okay, now what you have to do, you have to arrange it in increasing order. That means low to high. So if you see here, this order of growth which I have given you, it's very important. See, so here compared to this order of growth, which is the highest value we have here? Here the highest value we have is 2 ka power n. See, last is n ka power n, which we don't have, then 2 ka power n. Okay, so that means your f1 is the highest. That means as per the increasing order, f1 will be the last one. So if you'll see option A and D, okay, because option B and C is not possible. Now we will check only option A and D. This two is only the possibility. Okay. Now next, if you'll see, we have now three value. One is your n ka power 3 by 2. Another one is your n log n. And the third one is your n ka power log n. Okay. Now let us compare n ka power any value is greater or n log n. So see here. This is your n log n. Okay. So n log n value basically you can say is lesser. Okay. N log n value basically you can say is lesser than n ka power log n. See, this all is in n ka power. Okay, or you can say k can be log n. Okay, so your n log n value basically is less than this one. Okay, so as per the order, n log n will come before that n ka power log n. Okay, so n log n, that means f3. So here f3 will come before n ka power log n. Okay, n ka power log n is f4. Okay, so f3 will come before f4. Okay, now what about f2? So this is n ka power 3 by 2. So here you can see n ka power 1 by 2, n ka power 3 by 2, like that. Okay, so that will have the lowest value even than n log n. So what will be the order? Here it will be f2, and the last I already told you f1. So the correct order is f2, f3, f4 and f1. Now let us compare. This is f3, not possible. Yes, the correct answer is option D. f2, f3, f4 and f1. I hope it's clear. So just if you learn this order of growth, you can solve this type of questions easily. Next, this is your GATE CSE 2021 question. Consider the following three functions. f1, that is 10 ka power n. So I'll write it here. f1, that is 10 ka power n. f2, that is n ka power log n. f3, that is n ka power under root of n. Okay. Now, which one of the following option arranges the function in increasing order of the asymptotic growth rate? Okay. So here also what we want, here also we need its increasing order. Okay. Now, to solve this type of question, which is in power. Okay. Now, if you will take log of this one. Okay. So it will become log 10 ka power n. So in log, power always goes on left hand side. So it will become n log 10. Okay. Now if we take log here, so it will become log n ka power log n. So log will go on that side, left side, so it will become log n log n. Okay. Same here, log of n ka power under root of n, so it will become under root of n log n. Okay. Now it will be easy for you to identify. Now if you see this properly, sorry. Now if you will see this properly, you can see that your log of log n, this one log n value actually is less than under root of n log n, and that value actually is less than your f1. That means you can say n into log 10. Okay. So here what is this one? This is nothing but your f2. So f2 value is less than f3 is actually less than f1. Okay. So the correct sequence of increasing order will be f2, f3 and f1. So now let us match the option f2. Yes. So the correct answer for this question is option D. Okay. Next. This is your GATE CSE 2023 question. Let f and g be the function of natural numbers given f of n is n and g of n is n square. Which one of the following statements are true? Okay. Now let us see. Option A says that f that belongs to big O of g. Okay. So that means we can say your f of n, big O means is less than or is equals to C dot G of n. Okay. What's the value of f of n? N. Is it less than or is equals to G of n value? N square. Yes. So n value is less than or is equals to n square. Option A is true. Now let us compare our second option, that is f of n is less omega, right? So it is greater than or is equals to G of n. F is greater than or is equals to G of n. Okay, here also we'll write f of n. Okay, so f of n value is n. Is n greater than or is equals to n square? No, here also this condition not satisfied. So option B can't be the correct answer. Now let us see the third option. It says that your f that belongs to little o. Okay, this is nothing but little o of G. Okay, so here if you will compare this one, so actually as your big O is compared, okay, so here your little this one little o will also be the correct one. Then option D, let us compare. So omega, that means it should be in the middle. Okay, so that is not possible over here. Okay, so the correct answer for this one is option A and C. Okay, next, this is your GATE CSE 2000 question. F of n is equals to 3 ka power under root of n. G of n is equals to 2 ka power under root of n log n, and h of n is nothing but n factorial. So which one of the following is true over here? Okay, so here also we need to do the comparison. Let us start with option A. Option A says that your h of n big O, that means h of n is less than is equals to f of n. H of n value is n factorial. N factorial is nothing but n ka power n. Okay. Okay, one more thing. In this question, actually you can solve this question by simplifying it. Okay. How I can simplify? So see, the first one, if you say f of n, that is nothing but 3 into n ka power under root of n. Okay, so here no simplification possible. Okay, so this is your f of n. If you will do now this h of n, so h of n, that is nothing but n factorial, and n factorial is nothing but n ka power n. Okay, so this you can understand by n ka power n. If you will take the third one, your third one is your this is nothing but this one, g of n. Okay, so g of n is your 2 ka power under root of n, then log n. Okay, now here in this one, actually if you will consider here, if I'll take this as it is in log, okay, so I can take it on left hand side, so it can become 2 ka power log n, and under root of n can go in the power. Okay, so it will become 2 ka power log n, and this is under root of n. Okay, you know that in the log, if you will have 2 ka power and here n to the base 2, okay, so as per the log formula, it can be written as your n ka power under root of n. So this is nothing but your g of n. Now it will be easy for you to understand. Now let us solve option A. So h of n is less than or is equals to f of n. Okay, so h of n value, that is n ka power n, is it less than is equals to your f of n, that is 3 n ka power under root of n. Okay, is this condition true? No. Why? Because your n ka power n is greater than this, not less than. So option A is not possible. Now let us see option B. Your h of n is less than or is equals to g of n. G of n is n ka power under root of n. And what is h of n? H of n is nothing but n ka power n. So is n ka power n is less than is equals to n ka power under root of n? No. N ka power n is greater than, because if you cut this one, what is n less than equals to under root of n? No, under root of n is less than. Okay, so this condition is also not true. Now g of n is not equals to big O of f of n. What is g of n? N ka power under root of n is less than is equal to, they are telling it is not less than is equals to f of n. F of n is n ka power n. Actually n ka power under root of n is less than is equals to this. Okay, but they said it is not, so this is also not the correct. So the correct answer is option D, but still we'll check once. So see, here f of n is less than or is equals to g of n. So what is f of n? F of n, that is your 3 into n ka power under root of n, is less than is equals to g of n, that is n ka power under root of n. Okay, so this is your n ka power under root of n, and this is your 3 into n ka power under root of n. Okay, so here you can say that your f of n basically is correct one. Why? Because what they said, it can be equals to. Now constant doesn't have any meaning, so it's n ka power under root of n ka power under root of n. Okay, so the correct answer for this question is option G. Okay, so that's all with your today's class. I have explained you asymptotic notation, and many previous year gate question we have solved on asymptotic notation topic. Okay, so please solve this question. Any doubt, any question, you can ask it in comment. Definitely I'll reply. And if you like my channel, please like and subscribe. Thank you.